gotta say, when I saw this image of a cosmic filament, well, it kind of blew me away.
Yeah, it's pretty amazing, right? This filament connects these two galaxies from the early universe.
And I mean, early universe, we're talking about just 2 billion years after the Big Bang.
It really is like a snapshot from the universe's baby book.
Seriously. A structure spanning 3 million light years, dating back to, like, the dawn of time.
Gives us a peek at how the very first galaxies formed.
And how they clustered together, right? Along these massive filaments.
Exactly. Filaments made of gas, dust, and of course, dark matter.
Okay, wait. Before we get too deep into the cosmic weeds, can we back up for a sec?
Sure.
For those of us who, don't have a PhD in astrophysics, what exactly are we talking about when we say cosmic web?
Okay, so picture the universe like a giant web. Not like the kind in your attic.
More like a cosmic spider web.
Right. But instead of those sticky silk threads, we're talking about these massive strands of gas, dust, and dark matter.
And these strands are the filaments.
Yeah, and they stretch across the entire observable universe. Galaxies form and gather along these filaments like beads on a string.
So this image we're talking about, it's basically one of these cosmic strings, right?
Exactly. A 3 million light-year-long string.
Wow. It took 150 hours of observation with that MUSE instrument, right?
You got it, the MUSE instrument on the Very Large Telescope in Chile.
That's some serious stargazing.
It is. The light from that filament traveled for almost 12 billion years to reach us.
Okay, but we've seen images of these filaments before, haven't we? What makes this one so special?
Well, this is the most detailed image yet, especially from such an early period in the universe's history.
Ah, okay.
And there's another thing. For the first time, scientists can trace the boundary between the gas inside the galaxies and the gas in the cosmic web itself.
So they can actually see where the galaxy ends and the web begins?
Yep.
That's pretty wild.
It is. It's like seeing where a river meets the ocean.
Okay, so this is telling us a lot about how galaxies form, right?
Right, and that's where dark matter comes in.
Ah, dark matter. Everyone's favorite cosmic mystery.
Yeah, it makes up like 85% of all the matter in the universe.
But we can't actually see it, right?
Not directly. It's invisible.
Okay, so invisible stuff making up most of the universe?
Spooky. How do we know it's even there?
We know it's there because we can see its gravitational effect.
So it's like it's there, but it's not there.
It's like the architect of the cosmic web shaping its structure and influencing how galaxies form.
So how does that work?
Well, think of dark matter as the framework of a skyscraper.
The scaffolding.
Yeah, you don't see it when the building's finished, but it's essential for holding everything together.
Okay, so if dark matter is the scaffolding, what's the building material?
The gas and dust we were talking about before.
The stuff that makes up the filament.
Exactly. That gas and dust are the raw materials for stars and planets.
So this gas is swirling around in the cosmic web, just waiting to form stuff.
Right. And this image gives scientists a chance to study how the gas flows along the filaments, which tells us a lot about how galaxies grow. So it's like a cosmic pipeline, delivering fuel to those galactic powerhouses.
Exactly. It's all connected.
That's amazing. So how did scientists confirm that dark matter is playing this crucial role?
How did they connect it to these filaments?
Right. I mean, they didn't just look at the image and say, yep, there's dark matter.
Well, no. They actually ran something called a simulation.
Like a video game of the universe.
Well, kinda. They basically created a virtual universe on a computer.
Using everything we know about physics and dark matter, right?
Yeah. And they were able to essentially rewind the clock and see how the cosmic web should have evolved over billions of years.
That's incredible.
And guess what? Their simulation predicted a filament structure remarkably similar to what we see in this new image.
So they basically said, if our understanding of dark matter is correct, we should see a filament that looks like this.
And there it was.
Wow. But how do we know that's the only explanation?
Well, scientists are always looking for alternative explanations.
Right.
You might have heard about some observations from the James Webb Space Telescope.
Yeah, I remember something about that. Was there a chance those observations could overturn all our theories about dark matter?
The James Webb Telescope is giving us a lot of new data about the early universe, that's for sure.
Yeah.
Some of it's definitely making scientists scratch their heads.
So it could change things.
It's a little too early to tell if those observations completely overturn our existing theories, but it's good to question what we know.
Of course, of course.
But this filament image we're talking about, this one actually reinforces our current understanding of dark matter and the cosmic web.
So it's like a puzzle. Some things are fitting together and some aren't.
You could say that.
I like it. So we've talked about the structure of the cosmic web, the role of dark matter, but what about the gas itself?
About it.
I mean, What exactly is it made of, and how does it flow through those massive filaments?
Well, that's where things get even more interesting, and this new image gives us some really good clues.
Okay, I'm ready to go deeper into the cosmic web. Lead the way.
All right, let's do it.
So we've got this massive cosmic web, right? Stretching across the universe.
Yeah, these filaments made of gas, dust, and dark matter.
And we know galaxies form along these filaments like beads on a string.
Right.
But I'm still a little fuzzy on the gas itself.
Okay.
How does it actually flow through these huge filaments? I mean, is it like a raging torrent or more of a gentle stream? What are we talking about here?
Well, it's a great question, and scientists are still trying to figure out all the details.
Makes sense.
But this new image we have gives us some clues.
Okay.
First off, let's talk about what this gas is actually made of.
Okay.
It's mostly hydrogen and helium, the lightest elements in the universe.
The basic building blocks.
Exactly. The primordial soup left over from the Big Bang.
Wow, so this is ancient stuff.
It is. And it's not just sitting still in these filaments.
It's moving around.
Yeah, it's constantly moving and swirling,
Okay.
interacting with the gravity of dark matter.
So it's like a cosmic river system.
Kind of, yeah. With currents and tributaries flowing toward regions of higher density.
The places where galaxies form.
Exactly.
So the gas isn't just flowing smoothly.
Well, there are definitely variations and complexities.
Like rapids in a river.
You could say that.
Cool. So how do scientists study these flows?
Well, they use images like this one to map the velocity and density of the gas.
So they can see how fast it's moving and where it's clumping together.
Exactly. Trying to understand how it's channeled and accelerated along the filaments.
I bet that's not an easy task.
No, it's definitely a challenge.
So this gas is traveling through the web, hitting these rapids, and then what?
Well, as the gas flows toward galaxy-forming regions, it can trigger bursts of star formation.
New stars are born.
Yep. The universe lights up with new stars.
And the gas is fueling all of this.
That's right. The gas is both the fuel for galaxies and the catalyst for their evolution.
Wow.
It's shaping the universe as we know it.
So all the galaxies we see today, even our own Milky Way?
All formed from this gas flowing through the cosmic web billions of years ago.
We're all connected.
We're our children of the cosmic web.
That's pretty profound when you think about it.
It is.
Makes you feel pretty small.
And connected to something much bigger than ourselves.
Exactly. So we've established that gas flows inward, fueling galaxy formation. But is it a one-way street?
What do you mean?
I mean, does gas ever flow out of galaxies and back into the web?
That's a great question, and it's something scientists are really interested in right now.
Okay.
Because it turns out that galaxies aren't just passive recipients of gas.
They can affect the flow?
They can. Sometimes they even push gas back out into the filaments.
So it's like a two-way street.
Exactly. A feedback loop between galaxies and the cosmic web.
Cool. How does that work?
Well, one way is through these powerful galactic winds driven by supermassive black holes.
Those things are intense.
They are. And these winds can blow gas back out into the cosmic web.
So it's like galaxies are exhaling.
You could say that.
And what happens to that gas?
Well, it can enrich the cosmic web with heavier elements that were created inside stars.
So it's like recycling on a cosmic scale.
Yeah, kind of. And these galactic winds can also regulate the rate at which gas flows into galaxies.
So they're not just blowing stuff out, they're controlling the flow too.
Right, they can prevent galaxies from growing too quickly.
So it's all about balance.
Exactly. It's a delicate balancing act between inflow and outflow, between galaxies and the cosmic web.
This is all so much more complex than I originally thought.
The cosmic web is a dynamic system, constantly changing and evolving.
So what are some of the big questions that scientists are still trying to figure out about all this?
Well, one of the biggest mysteries is how exactly gas is transported across such vast distances.
Yeah, how does it actually get from point A to point B in the web?
Right. Is it a smooth, continuous flow, or are there bursts and interruptions? And what role do magnetic fields play?
Now, I guess the ultimate question is, how do all these flows determine the types of galaxies that form?
Exactly. And how fast they evolve? Another big question is how the cosmic web itself has changed over time.
I mean, it hasn't always looked the same.
Right.
Right.
Did it change as the universe expanded? And how did those changes affect the galaxies we see today?
It's like every time we answer a question, 10 more pop up.
That's science for you.
Okay, so we've talked about the structure, the dark matter, the gas flows, the mysteries. What's next? What's on the horizon for cosmic web research?
Well, there are a lot of exciting things happening right now.
Like what? Give us a sneak peek.
Well, for one thing, we're building even more powerful telescopes.
Bigger and better.
Exactly. both on the ground and in space. These new telescopes will be able to see even fainter and more distant objects
So we can map the cosmic web in even greater detail.
and study gas flows with even greater precision.
That's awesome. What else?
Well, another exciting development is the use of artificial intelligence.
AI. For studying the universe.
It's already happening.
How does that work?
Well, these AI algorithms can help us analyze the huge amounts of data that these new telescopes are collecting.
Data we couldn't possibly analyze on our own.
Right. AI can help us identify patterns and connections that we might miss.
So we're using the power of AI to unlock the secrets of the universe.
Pretty much.
I like it. So what kind of discoveries do you think we might make in the future?
Well, it's hard to say for sure,
Of course.
but I think we're going to see some really amazing things in the coming years.
That's exciting.
It is.
I can't wait to see what the future holds for cosmic web research.
Me too.
This has been a truly mind-blowing deep dive.
I'm glad you enjoyed it.
Thanks for joining us on this cosmic journey.
My pleasure.
And for all of you listening, remember that the next time you look up at the night sky, all those stars, all those galaxies are connected by this vast and intricate cosmic web, a web that stretches across billions of light years and billions of years of cosmic history.
A web that holds the secrets of our origins and hints at the infinite possibilities that lie ahead.
Until next time, keep looking up and keep wondering. Okay, so we've taken this incredible journey through the cosmic web, right?
Yeah, we've seen how it's structured
We've talked about the role of dark matter and all those crazy gas flows,
and how it all ties into the formation and evolution of galaxies.
right? And we've even touched on some of the big mysteries that are still out there.
The stuff that keeps cosmologists up at night.
Exactly. But I'm curious, where do we go from here? What tools and techniques are scientists using to push the boundaries even further?
Well, you already mentioned one of the big game changers.
The James Webb Space Telescope.
That's right. It's given us this incredible ability to look back in time to see the universe as it was billions of years ago.
And that's helping us understand the early stages of the cosmic web, right?
Absolutely. But there are other exciting instruments and projects on the horizon, too.
Really? Like what? Give us a sneak peek into the future of cosmic web research.
Okay, well, for one thing, we're developing even more powerful telescopes.
I figured that was coming. Always got to build bigger and better, right?
Exactly. And these new telescopes will be both on the ground and in space.
Okay.
And they'll be able to detect even fainter and more distant signals than ever before.
So we can see even further back in time.
And map the cosmic web in even greater detail.
Awesome. Anything else?
Oh, yeah. We're also starting to use artificial intelligence and machine learning.
Wait, AI for studying the universe? That sounds like something out of Star Trek.
It might sound futuristic, but it's happening right now.
So how does that work?
Well, these new telescopes generate these massive amounts of data, right?
Way too much for any human to sift through.
Exactly. So these AI algorithms can help us analyze all that data.
So they can find patterns and connections that we might miss.
Exactly. They can even help us create more sophisticated simulations of the cosmic web.
So we can test different theories and refine our understanding?
Exactly. It's really a game changer.
So it's like we're combining human ingenuity with the power of AI.
To explore the universe in ways we never could before.
I love it. This is all so fascinating. It really makes you appreciate the collaborative effort involved in all of this.
Yeah, cosmology is a team sport these days.
And it's not just about astrophysics, right? It's pulling in expertise from computer science, math, engineering.
And every new discovery pushes us to think bigger, to challenge our assumptions, and to imagine new possibilities.
Exactly. It's not just about finding answers. It's about embracing the unknown and being open to new ideas.
Because the universe is full of surprises, that's for sure.
That's what makes it so exciting.
And as we continue to explore the cosmic web, I have no doubt we'll uncover even more breathtaking discoveries.
Discoveries that will reshape our understanding of the universe and our place in it.
Absolutely. It's an incredible time to be a cosmologist.
Well, I have to say, this has been an absolutely mind-blowing deep dive. I feel like I've learned so much.
I'm glad you enjoyed it.
And for all of you listening out there, remember that the next time you look up at the night sky, all those stars, all those galaxies are connected by this vast and intricate cosmic web.
A web that stretches across billions of light years and billions of years of cosmic history.
A web that holds the secrets of our origins and hints at the infinite possibilities that lie ahead.
So keep looking up and keep wondering.
And on that note, thanks for joining us for this incredible exploration of the cosmic web.
It's been a pleasure.
Until next time, keep exploring.